Hey, look at that guy. I know that guy. Do you guys know that guy? That is the derivative definition thingy. You guys remember that? The derivative definition thingies? Here, let's write it out really quick. The limit as h approaches 0. The h goes on the bottom because that is the horizontal distance. And on the top, we would have f with x plus h plugged into it. And then we would have f of x. Okay, now we could, if we wanted to, if we were trying to find the derivative at a location, we can plug in the a for these x's. But that's not what we're doing right here. Okay. All right, so do you guys see the similarities here? How this guy kind of looks like that guy? So whatever a is, whatever we're plugging into this right here, into the f, we end up getting 1,000. All right, so this right here becomes 1,000. All right, this one right here, when we plug in a, and I don't know what a is like a number, right? When we plug a into it, a plus h, we get 10 plus h raised to the third power. So here's the big question. What is the f? What is the f that we're taking the derivative of? Because you guys know that this right here equals f prime of x. So that means this right here equals f prime of x. What is, well, actually I shouldn't say of x. A is plugged into it right now. What is f? Yeah, I think so. X to the third power? Is that our function? I think so. Okay, so let's think about that for a second. So if it's x cubed, that means it would be a plus h to the third power minus a to the third power over h. And we're taking the limit as h approaches 0 on this. Okay, guys. Do you guys know what a has to be? We could probably figure it out by looking at... Oh, you think it's 10?
And therefore...
A equals 10? Okay, if I do 10 to the third power, that'll give me 1,000? Oh, snappity waggity daggity. Okay, so what do we get? What do we get? I mean, you could do this. You could just go like, oh, this is f prime of x equals 3x squared. And then you can plug in your 10 to that and find your answer like so. What's 10 raised to the second power? It's 100. 100 times 3 is 300.
Whoa.
So some of you guys are like, oh, I multiplied this out like to the third power. It works. It works. But I wouldn't want to do that. So the short way of solving this is finding the h and finding the a. And if you can figure that out by knowing the definition and looking at what they're giving you, then you can take the shortcut. And that the shortcut's the power rule. I like that. If that's not you, then dang it. 10 plus h. 10 plus h. 10 plus h. I know. So we get 100 plus 20h. Plus h squared. Then I have to multiply this by 10 plus h. You guys are jerks. I don't like you. Okay, so 10 times 100 is 1,000. 10 times that is going to be 200h. And then 10 times that's going to be 10h squared. And then we have to multiply the h to all those. So I went like this. And now I have to do the h. And so I get 100 h's. And then I have 20 h squareds. And then I have an h to the third power. That is all right here, right? So we're going to minus 1,000 right here. And we have h. H is going to go to 0. Oh, h goes to 0. Yay. So I'm taking the limit as h goes to 0. Okay, but can I simplify stuff on top before I make h go to 0? Yes. Killing spree. By 1,000. By 1,000. Oh, he's not screaming. Anything else? Which one? Oh, you said 300h. Okay, because we're simplifying. 300h. How many h squareds? 30h squareds. And then we have an h to the third power. Okay, that's it, right? Okay, can we simplify that a little bit more?
Take out an H.
Ooh, the H's are canceling out. Oh, snap. That's a 2 now. So let's clean it up. We have the limit as H approaches 0. And now all we have is 300 plus 30H plus H squared. As H goes to 0, this guy dies, this guy dies, and what are we left with?
300.
Oh, okay.
That's still evil.
Oh, yeah, why do they?
So when we use direct substitution right here for this, we plug the zeros into the H's for direct substitution. That's why they die. And you're left with 300, and that's your answer.